Solve the inequalities. All right, so we've been using this idea of basically finding the zeros in the vertex of the function and then graphing the function. So when we worked out the previous problems, a lot of times the quadratics were factorable. In this particular case, though, when you look at example A, it says x squared plus 2x plus 3. If that was factorable, you'd have to be able to find factors of 3 that add to give you 2, right? So factors of 3 that add to give you 2. But the only factors of 3 that exist are 1 and 3, and they add to 4, not to 2. So this is not factorable. All right, so let's do something else instead. Let's find the vertex. So remember, the vertex is easy. It's just h is equal to negative b over 2a, right? So negative b would be negative 2 over 2 times 1. And then you get negative 2 over 2, negative 1. And remember, this is the x-coordinate of the vertex. We can get the y-coordinate by plugging negative 1 in. So to get k, or the y-coordinate, we just do negative 1 quantity squared plus 2 times negative 1 plus 3, right? And when you do that, you end up with 1 minus 2 plus 3, or in other words, 4 minus 2, which is just 2. Okay, from there we have our vertex. So our vertex, then, is simply equal to the point negative 1, comma 2. All right, let's go ahead and plot that on our graph. Remember, you can plot a parabola with strictly its vertex, right? You can at least get an approximation of where it's located and what it looks like. So if I go negative 1 on the x-axis, that would be here. And if I go up 2 on the y-axis, that would be here, and I get a point right there. Now, where's the parabola going to go from here? Is it going to open down, something like this? Or is it going to open up, something like that? Well, the answer is it's going to open up. And why? Because the leading coefficient, the number in front of x squared, is positive. Now let's look at the graph and try to answer the question. This question asks, where is this equation or function greater than 0? Greater than 0 means above the x-axis. Where is the graph above the x-axis? Well, the answer is the graph is above the x-axis everywhere. For all numbers on the x-axis, this graph or function is always greater than 0. So the answer to our question is basically all real numbers. All real numbers. Now you can say that a little differently. You can say from negative infinity on the x-axis to positive infinity. Basically, that's where the function is greater than 0. Okay, let's look at the next one then. For the next one, it's the same idea. We want to see if we could find the zeros and the vertex of the function. So if it says x squared minus x plus 2, is that factorable? Let's see, it's got factors of 2 that add to 1, right? It would have to be factors of 2 that add to give you negative 1, basically. But factors of 2 are only 1 and 2, and they add to 3. They don't add to 1, so this is not factorable. So when it's not factorable, you could either try the quadratic formula if you want, but when you check that here, you're going to see that there actually are no zeros of the function. But regardless of whether you did that or not, let's start by at least plotting the vertex and figuring out if it's even worth looking for zeros, right? So let's go ahead and try to do that. So we're going to plot that by first finding the vertex. So in order to find the vertex, remember we use the h formula, which is negative b over 2a, and that'll be negative negative 1 or positive 1 over 2 times 1. So that's occurring at 1/2 then, and then we plug 1/2 in to get k. So we have 1/2 squared minus 1/2 plus 2. Well, that's the same as saying 1/4 minus 1/2 plus 2. And if you wanted to put them all over a common denominator of 4, let's say, we'd have 1 minus 2 times 2 gives you 4, so it'd be 2 here, and then the 2 becomes an 8 because 8 over 4 is 2. So it's just getting a common denominator for all your pieces there. So you end up with 7/4 as your fraction. All right, so your k is 7/4, your h is 1/2. All right, so that means that our vertex for this parabola is at the point 1/2, comma 7/4. All right, so if you plot that, it's not important that 7/4 is, it's a fraction, but, it's basically almost 2, right? So in other words, it goes in 1 3/4, so 1 3/4. So it should be easy to plot. In fact, if you want to give yourself some extra space on the graph, you can actually use maybe every 2 tick marks here to represent sort of 1. All right, so let's think about where the vertex would be then. It would be going 1/2 on the x-axis, right? And then going up almost 2, right? 1 3/4. So about here, let's say. Okay, from there, we have to think, does the parabola open up or does it open down? Well, we can see that because the leading coefficient of x squared here is 1, that we're going to be opening up. And because it opens up, it means there are no zeros. Remember what a zero is. A zero is an x-intercept. It's where the graph crosses the x-axis. So it doesn't cross the x-axis here, so there are no zeros. So it's a waste of time to even look for zeros in this particular problem. All right, but once we know that's the case, then we have to answer the question, where is the function less than or equal to 0? In other words, where is the function negative? Well, negative answers only occur down here for y, right? And there's no part of that graph or function that crosses below the x-axis. So the answer for this is basically the empty set, or you can say there are no real solutions. So no real solutions. Right? There are no real solutions for this problem because the graph does not cross below the x-axis, so the y is never negative, nor is it ever equal to 0, right? It's strictly greater than 0 across its entire domain.